Hello students, in this video we are going to study about excitation and ionization energy as well as excitation and ionization potentials. So basically we are going to study about four different terms: excitation energy, ionization energy, then excitation potential, and then ionization potential. So let's start with the first one, which is excitation energy. Now this is quite understandable by its name only. It's a kind of energy which is required by the electron of an atom to jump from ground state to any excited state. Means the energy required by the electron to get excited or to get a jump from lower energy level to higher energy level, that is called excitation energy. So excitation energy of an atom is defined as the energy required by its electrons to jump from ground state to any of the excited state. So that much energy is called excitation energy, and it is equal to the difference between those two energy levels in which electron is transiting. So for hydrogen atom, if we talk about hydrogen atom, its electron is present in first energy level, right? At the ground state, the electron in case of hydrogen atom is present in first energy level, and at first energy level its energy is minus 13.6 eV. Now if it is transiting to first excited state, now first excited state means the first next level or the first higher level above it. So first excited state means n is equal to 2, because at n is equal to 1 it is already present. So for it, first excited state is the first higher level, that means n is equal to 2, and energy corresponding to it is minus 13.6 upon 2 square, that is equal to minus 3.4 eV. Now if electron is transiting from E1 to E2, right? So this is its initial state, this is its final state. Then the excitation energy required, the first excitation energy for hydrogen atom is equal to E2 minus E1, because its electron transit from 1 to 2, and its value is equal to minus 3.4 minus 13.6, that means 10.2 eV. So this much energy is required by the electron to show this excitation. Similarly, second excitation energy for this hydrogen atom is equal to E3 minus E1, because it is present at n is equal to 1, and the second higher state it has is n is equal to 3. That means second excitation energy is E3 minus E1, and its values are minus 1.51 minus 13.6. That means it is equal to 12.09 eV. So this is the excitation energy. Now come to ionization energy. No, so it is the energy required to knock an electron completely out of the atom. In the case of excitation, electron was not going out of the atom, it was just going from some lower energy state to higher energy state, and the atom was getting excited. But in case of ionization energy, the electron will leave the atom entirely, and that atom will become an ion. So for ionization energy, the final state, energy state on which electron is going is at infinity, means it is completely going out of the electron. So ionization energy is the energy required to completely knock out, or we can use the word remove the electron, completely knock out the electron from that atom or from atom. So that much energy is called ionization energy. That means if electron is at n is equal to 1, then to completely get it out, we have to take it to n is equal to infinity. If it is at n is equal to 2, again we have to take it to infinity to get it out of that atom. That means ionization energy, we can find ionization energy by taking final state as at infinity. So ionization energy for hydrogen, this is equal to E infinity, that is E final minus E initial, that is 1. So now E infinity is minus 13.6 infinity square, right, because it was minus 13.6 n square. Now we have infinity at the bottom, at the denominator, that means this is not defined, or this is 0, the value for it is 0. So 0 minus 13.6, that means we will get the answer 13.6 eV. So this much energy is required to ionize the hydrogen atom. So these were the energies, excitation and ionization energies. Now let's move to the potential. So the third term is excitation potential, and it is the accelerating potential which should be given to the bombarding electron so that sufficient energy can be imparted to the target atom and it can raise one of its electron from inner to the outer orbit. So excitation potential is the accelerating potential which gives an electron, right? This accelerating potential gives an electron sufficient energy to excite the target atom by raising one of its electron from inner to outer orbit. So we read about excitation energy, from where that energy is coming. So that energy is coming from excitation potential. Excitation potential is the accelerating potential that is providing that energy to electrons so that it can excite the target atom by taking one of its electron from inner orbit to outer orbit. So first excitation potential for hydrogen, again it will be given in a similar manner just as we give energy, but this time it will not be E2 minus E1, it will be the potentials. So if E1 is minus 13.6 eV, then potential for this is minus 13.6 V. Similarly, if E2 is minus 3.4 eV, then potential for this is minus 3.4 V. So we have to take the difference of these potentials this time. That means first excitation potential for hydrogen is minus 3.4, which is the final one, because electron is transiting from inner to outer, that means 1 to 2. So this is the final state, minus 3.4 minus 13.6, that is 10.2 volts. Similarly, second excitation potential is equal to minus, second excitation potential के लिए we have to take electron from first to third, that means it should be the energy of third level. So it is minus 1.51 minus 13.6, and if we solve it we get 12.09 volt. So this is the excitation potential. Now the last term we have is ionization potential. Similar to the concept of ionization energy, now we have to take the electron to infinity, that means out of the atom. So out of the atom there is no potential, right? So the accelerating potential which gives to a bombarding electron sufficient energy to ionize the target atom such that it go out from the atom. That means it go from its own state to the to just out of that atom. So it is again the accelerating potential gives an electron sufficient energy so that it ionize the target atom by knocking out the electron from atom. So in this case, electron will go completely out of that atom, and that's why the final potential, electron will have the final potential or the potential at final state, that potential will be 0. So first ionization, or in this case there is no first or second, simply the ionization potential for hydrogen atom is 0 minus 13.6, that is 13.6 volt, which means electron is going from first energy level to infinity. So at this level the potential is minus 13.6, and at out of the atom it becomes 0. So for final state it is 0, and for initial state it is minus 13.6, and we have to take the difference to find the ionization potential for hydrogen atom. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.